Alright, hey guys, so moving on to lesson 11.7. We're going to talk about cones today. The first or the only vocabulary definition for this lesson is lateral surface area of a cone, alright, which consists of all segments that connect the vertex with the points on the base edge of a cone. Okay, and I'll show you my quick diagram, but you can see it in the notes as well. There's your cone, you have the base, and then the lateral surface is this region right in here. Okay. So surface area of a right cone, you're going to see S or SA depending on the book and the worksheet. All right, so S stands for surface area, so does SA, surface area, and it's going to equal pi r squared plus pi RL. Okay, and I'll explain what L is as we get started. Well, actually, it's in your notes right here, so I'll point it out. L is the slant height. So the height of the cone would go from the very tippy top straight down to the center of the circle. That would be the height of the cone, but this slanted side, cursive L, is called your slant height. Okay. And then we're going to also be finding the volume of a cone, and the volume formula is the same as our previous volume formula that we used in the last lesson, which is 1/3 BH. B meaning the area of the base. So since we're dealing with cones, the area of the base or the shape of the base is a circle. So B will be pi r squared. All right. So that is the entire front side of the notes, just a lot of highlighting and volume. So I'm going to jump right into the problems. So the first problem on the back side, we have a cone. The cone has a radius of 3, has a slant height of 5, and it has a height of 4. So again, if I was labeling, height is 4, slant height is 5, and radius is 3. You're asked to find the surface area of the right cone. So your surface area formula is pi r squared plus pi RL. So it's just a matter of substituting in and simplifying. So pi 3 squared plus pi times 3 times 5. Okay, so this is going to be 9 pi plus 15 pi. Those are like terms, so you can add them together to get 24 pi, and it's centimeters squared. Okay, so that's problem number 1. Problem number 2, there is no diagram, so we'll have to sketch our own. It's a cone, so I'm just going to erase this. Alright, so for problem number 2, it says a right cone has a diameter of 1.8. So the diameter is given as 1.8. That's the whole thing. And then it has a height of 3 inches. Okay? And you're again asked to find the surface area. Okay, so we're going to use that same formula. Surface area is equal to pi r squared plus pi RL. So coming over to the side again, I can label my height is 3. My diameter is 1.8. So if my diameter is 1.8, divide that by 2 to get the radius is 0.9. All right. And then the last thing we have to figure out is the slant height, which is not given this time. But does everyone see this right triangle right here? Okay, and I can label this now 0.9 since I know it's 0.9. I'll get rid of that 1.8. Okay, we can use Pythagorean theorem to solve for the slant height. It's 3 squared plus 0.9 squared equals L squared. So it's 3 squared plus 0.9 squared equals L squared. Okay, so you're going to have 9 plus 0.81 equals L squared. So it's 9.81 equals L squared. Take the square root of that, or actually I'm going to leave it as the square root of 9.81. leave it like that so that you're not using an approximated value to do another calculation. Okay, so I'm going to leave it as the square root of 9.81. Now, if I was asking you to actually find the slant height, I'd probably say round to the nearest tenth or hundredth, and you plug that back into your calculator. But since we're using that value to find another calculation or to do another calculation, I want to use the exact value. Okay, so now plugging all this information in, I have pi 0.9 squared plus pi 0.9 times the square root of 9.81. Okay. So for this problem, I would probably, the directions would probably say approximate and round. All right, so because what it comes out to is 0.81 pi plus 0.9 pi square root of 9.81. That's a pretty ugly answer. For this type of problem, it would probably say approximate. So I'd plug that into my calculator to get approximately 11.4 inches squared. Okay. Problem number 2. Or sorry, that was problem number 2. So problem number 3. Alright, so problem number 3. Now it says to find the volume of the cone. Okay, so for the first cone, it's actually the same diagram as the very first problem we did today. We have a cone, has a radius of 3, a height of 4, and a slant height of 5. So it's radius of 3, height of 4, slant height of 5. The volume formula is 1/3 BH. All right, base. What shape is the base? It's a circle. How do you find the area of a circle? Pi r squared. So I just need r and h. I don't even need the L for this problem. 1/3 times pi times 3 squared times 4. So 1/3 times pi times 9 times 4. 1/3 times 9 is 3. So 3 pi times 4, which is 12 pi. And its volume, units are centimeters, so centimeters cubed. Okay. So that's problem number 3. Problem number 4. Problem number 4. A right cone has a radius of 5 feet and a slant height of 13 feet. We want to find the volume. So I have a cone. It says that it has a radius of 5 and a slant height of 13. We want to find the volume, which is 1/3 BH. The base is a circle, so it's going to be pi r squared h. So I know my radius is 5, my slant height is 13. I don't need to know my slant height. What I really need to know is my height. Okay, because if I try to substitute into the formula, I don't know if that's better, guys. Is that better? Sorry, I just noticed that it was kind of dark in here, but now there's a glare. Alright, so that would be good, but I can't hold the chandelier, so we'll have to make it work. Sorry, guys. Alright, so I don't know my height, but I can use Pythagorean theorem to solve for the height. Okay, to solve for the height, this is my h, 5, and 13. So this is going to be h squared plus 5 squared equals 13 squared. So h squared plus 25 equals equals, where am I? 169, sorry, 169. Subtract 25 from both sides to get 144. Take the square root of both sides and you'll get 12. This was a Pythagorean triple, a 12, 5, 13. So you may have known that without doing Pythagorean theorem, which is fine as well. All right, so now I can substitute in all my values. 1/3 times pi times 5 squared times 12. So 1/3 times pi times 25 times 12. I'm going to multiply the 1/3 into 12 because that simplifies quickly to 4. So now it's 4 times 5, or times pi times 25. 4 times 25 is 100, so it's 100 pi. What are my units? What problem am I on for? Feet cubed. Okay. All right, so we have a few more problems to work through. Okay. So for problems 5, 6, and 7, it asks you to find the indicated measure. So for problem number 5, sorry guys. For problem number 5, it says a right cone has a surface area of 444 square inches and a radius of 7 inches. Find the slant height. So start by writing down the formula that you're going to use. All right, so since it talks about, number 5, since it talks about surface area, I know my surface area formula is pi r squared plus pi r l. And then fill in anything that's given. The surface area is given as 440. The radius is given as 7. And you don't know the slant height. And then clean up and simplify as much as you can. So that's 49 pi plus 7 pi L equals 440. From there, I can subtract 49 pi from both sides. Trying to isolate the L. So now I have 440 minus 49 pi is equal to 7 pi L. And then I'm going to divide both sides by 7 pi. All right, so the slant height is equal to 440 minus 49 pi divided by 7 pi. Okay, for these problems, I will definitely be asking you to round to the nearest something, whether it's whole number, tenth, whatever my directions say. So you plug this into your calculator to get that L is approximately 13 inches. Okay. All right, let's try another one. Problem number 6. A right cone has a volume. All right, so I'm going to stop. I'm going to write my volume formula. 1/3 BH. The volume is 528. It has a diameter of 12 meters. Find its height. And it's a cone. So if it's a cone, the bottom is a circle. So B is pi r squared times h. Okay, so now I can fill in the rest of the information that's given. You're told the diameter is 12. So if the diameter is 12, what's the radius? Divide that by 2 to get a radius of 6. All right, so now you're going to square the 6. So 1/3 times pi times 36 h You multiply those together. 1/3 times 36 equals 12 pi h. Then divide both sides by 12 pi. Again, for this one, I would most likely tell you to give me an answer rounded to the nearest something. We'll round to the nearest whole number because that's what I did in the notes. H is approximately 14 meters. All right. And I think there's just 2 more problems. For problem number 7, cone A and cone B are similar. So as soon as I hear that word similar, I'm thinking scale, factor, A to B, ratio of areas, A squared to B squared, ratio of volumes, A cubed to B cubed. Okay. All right, so it says the radius of cone A is 4 centimeters and the radius of cone B is 10. The radii, the heights, the lengths, the widths, those are linear dimensions. That's to give you your scale factor. So it says it's 4 to 10. So 4 to 10 is my scale factor. Simplify it to 2 to 5. All right, then it says the volume of cone A is 134. Find the volume of cone B. So I need the ratio of volume. So I'm going to take my simplified scale factor and cube both of those values. All right, and that is going to give me my ratio of volumes, which is 8 to 125. This is what I need to use in order to set up a proportion. 8 to 125 is equal to the volume of the small over the volume of the large. Volume of A to volume of B. So it's 134 was given as the volume of A. I don't know the volume of B. So now it's a proportion, and you just have to cross multiply and divide. And when you do so, you're going to get that X is equal to 2,093.75 centimeters cubed. Okay. And the very last problem from this lesson. Okay. So the last problem says find the total, find the volume of the composite solid. Composite solid is just made up of more than one solid. So you have a cylinder and a cone. Find the volume of the cylinder, find the volume of the cone, add, and that's all you have to do. So the total volume is equal to the volume of the, what did I write first, cone, plus the volume of the cylinder. And what I'm going to do is I'm going to write down the volume formulas for each. Okay, for a cone, it's 1/3 base times height. For a cone, it's just for a cone, it's 1/3 base times height. For a cylinder, it's base times height. A cone has a circular base, so B becomes pi r squared h. A cylinder also has a circular base, so that's pi r squared h. Okay, so looking at the diagram, what is the radius of the cone? It's 2, so it's 2 squared. And what is the height of the cone? It's 4. All right, I'll show you just in case you don't have it in front of you. The radius of the cone is 2. The height of the cone is 4. Okay. What is the radius of the cylinder? Also 2. What is the height of the cylinder? 5. Okay, so the radius of the cylinder is also 2. The height is 5. So I have 1/3 pi times 4 times 4 plus pi times 4 times 5. So it's 1/3 times pi times 16 plus 20 pi. So it's going to be 16 over 3 pi plus 20 pi. Alright, those are like terms. You can add the coefficients together, which will give you 76 over 3 pi inches cubed. Okay. And that is finally it. Okay, that is the end of lesson, what number am I even on? 11.7. Jump over to the textbook to get your homework done. I'll see you guys for 11.8 later on. Bye.